Hello, Mechatronics marker. This is myself, Josh, and Dave's attempt at assignment 2. Josh will do the demo first, then I'll speak for a bit, and then Dave will explain some of the code later on. I'm sure you're very excited. I hope you enjoy.
This is our setup with the 4-digit SSD, the RGB LED, potentiometer, the lock button, unlock button, and our serial monitor. When I type in the password, it will start displaying the information every second. And now press the lock button. It starts counting down, and the sequence continues. I can change the brightness, so now it's getting dimmer, and it's getting brighter. This is the unlock button.
Hi, I'm Noah, and I'm going to talk to you about our group's aha moment. No, not that kind of aha, more of a learning aha. So Josh has an older Arduino kit compared to the ones Dave and I have, and we all individually wired our boards up and imported the same code onto them. And the problem was that Josh's RGB wasn't showing the right colors, whereas Dave and mine's worked fine. So that was a problem. And it probably took us about half an hour before we realized that it's because Josh's RGB is common cathode, whereas the one Dave and I have is common anode. So all we had to do was solve that problem was on Josh's board, switch the common pin to go to the ground and invert all the pulse width modulation values in the code so that reflected the right color. Now I'm going to talk about some of the differences between working individually in AT1 and working as a group in AT2. So I would say AT1 was probably more stressful as it was all up to me. So if I couldn't get the code working, then I was kind of screwed. Whereas in assessment task 2, I've got the combined knowledge of Dave, Josh, and myself. So we're able to bounce ideas off each other and solve problems. And that's where we each have our own different strengths and weaknesses. However, one of the problems of working in a group is people not meeting deadlines, i.e. me editing this video last minute, or just a general disconnect and not being on the same page about things with other group members. It can also be tricky to find a time where everyone's available for a meeting, or sometimes you might have group members that are unresponsive on group chats. And that's why good communication is really fundamental and important for group projects like this.
Right, let's talk about what's new from our code from last time. So we've got digit maps this time, we've got a password we set here. A digit map just helps us to save all of our digit numbers on the SSD instead of doing it every time. We've got some shortcuts here on how to turn RGB light on and off at once. Common anode means it's 255 is off, and so high is low and low is high pretty much. Yep, we've used booleans here so we can go true, false, true for each color. It's a bit quicker. So we've got for our segments here on display, we can use the patterns for each segment. Use them, and then yep. So just the command keep the SSDs blank, so there's nothing on the screen. Everything's low, so digits are low, but everything else is high because of the common anode. So we've got our password handler here. So we've done pretty much we've got a serial read. So we're going to check the input of the person. If the attempt equals the saved password, it's correct, and we can go true, and then it'll be enabled. For later. So also look at what else we look at. So we've got our main loop here. So it starts in state 1, brightness, update brightness 2, whatever it should be. That is based on the potentiometer, which is I've got a command up here actually. Yep. So we're just dividing it by 4 to get the potentiometer reading to 255. And then so we're starting in state 1 and we go to state 6, update brightness again, checking it. SSD is off when it's not locking. Red light, yes, maybe report. We're going to check if we can report to the serial output. And if unlock button is pressed, we're going to start our unlock sequence, which is up here again. So we're going back to state 1, and that's about it.
The only difference with our flowchart is that it checks all the brightness and password at every state. If the potentiometer is adjusted, the brightness is also adjusted. If not, nothing happens. And at the same time, the password is checked and displays a secret monitor every second. If not, it just waits for the lock button to be pressed. And it moves from state 1 to 2 all the way to state 6, as this is known as an asynchronous system. Our schematics on Tinkercad is the same as what we have in real life, except for the 4-digit SSD. We have D1 and D2 connected to pin 3 and 8.